Hi, we have the AP Physics 1 past paper 2023. We are discussing free response question section. In this part, we have the question number 2, which carry the 12 point. A student conduct experiment to determine the acceleration of a cart. The cart is released from the rest at the top of the ramp at the time t is equal to 0, moves down the ramp. X is defined to be the parallel to the ramp with its origin at the top. As shown in a fig, origin is considered at the top of the inclined plane. The student collects the data in the following table. Position at different position at different time. They get to know what is the time taken by the car to reach at these position. So now indicate which quantities could be graphed yield the line, so which slope could be used to determine the acceleration. You may also use the column in a table as needed to record any quantity including units that are not already in a table. So what should be at vertical axis, what should be at horizontal axis? So I have taken the time square, t square. So I have the two quantities, one is position, one is time square to determine the acceleration. So position should be at vertical axis, horizontal square should be time square. Why I come to these two quantities? As we know that S is equal to VIT plus half AT square because it starts from the rest, so initial velocity is equal to 0. So I have x is equal to 1 by 2 at square. So x over t square is equal to 1 by a square. So x delta y over delta x is set for the slope. So x is along vertical axis, t square is along horizontal axis. So that's why I have labeled these. Now on a following grid, plot the appropriate quantities to create the graph that can be used to determine the acceleration of the cart as it rolls down the ramp. Clearly scale and label the axes, including unit as appropriate. Draw the straight line best represent the data. So from these two quantities, x and t scale, I have make the data. Horizontal scale is the time scale, vertical scale is the position. So that's the best line that represent the almost touch all the points in the table. Okay. Now next part, using the line, draw the in part A, calculate the experimental value for the acceleration of the card as rolled down the lamp. So I take the 2.55 from this one and then from this one to 0.06. So this one we can calculate the value of the delta y change in position delta t square as corresponds. So the answer is slope that 0.38 meter per square. As we discussed in the previous case, slope is equal to s over t square equal to 1 by 2a, but we have to calculate only acceleration. So 2 should be moved on the other side to multiply the acceleration. So slope is 0.38 multiplied with 2, that is 0.76. Acceleration is 0.76 meter per second square. So that's the answer from the experimental value. So you can also take conclude that you can take the value 0.55 from the this value and zero time is 0.144 and the other value 0.16 is to take the difference between these two quantities, that is along the vertical axis, horizontal axis. So these two quantities from vertical side, these two quantity from horizontal side, so you can reach these points. Now, the students are asked to determine the experimental value of the acceleration due to gravity using their data. What additional quantity do the student need to measure in order to calculate experimental G from A? So as we come to know that cart is moving down and there is the weight acting downward. There is a weight is have the two component. Mg sine theta is the can you can say is the responsible to moving the down cart. So there is angle theta is most important thing the students have to measure. So inclination of the surface should be measured. To find the theta, we can use the length of the ramp, the distance along the top to the bottom, and the height of the ramp vertical from drop to the bottom. So sine theta is equal to h over L. We can measure the sine theta to use the acceleration. How? Because we have the vertical mg sine theta is responsible for moving down the surface. Now, next part, write the expression value for the experimental value in term of g as I described earlier. F is equal to mg sine theta, F is equal to ma, m should be cancelled, a is equal to g sine theta, so g is equal to a by sine theta. We have calculated a in previous case, in this case, and the sine theta from, if we come to value with the theta, we can calculate sine theta, so that's the answer of experimental g. Now, the student calculate the value of experimental G to significantly lower than the expected value of 9.8 meter per second square. What is the physical reason other than the friction or air resistance that could lead a significant difference in experimental determined value of the G experimental G? There are several physical reasons that could make the cart slow down more than expected, making the acceleration smaller so that calculated g would also be smaller. One of the main reasons is the wheel of the cart have to the spin. If the cart wheel have their own moment of inertia, they resist the spinning because they slow down the motion because of their mass and the shape. As we know that if there is a greater moment of inertia, there is less angular velocity to conserve the angular momentum. So that's the reason the spinning resist by the moment of inertia that would cause the slow down the cart motion. Next reason might be the ramp might not be straight or smooth, that could slightly curve or bumpy. That's also the reason for the slow down the cart motion. So that's the acceleration would be less than the expected value. Now explain the physical reason you identify in part C1 that would lead to decreased experimental determined value of the G. Now, what's the reason behind how we can say the moment of inertia will cause this? When wheel rotate, they steal some of energy to spin the wheel that would otherwise go to the cart forward translational speed. Because the cart moves slower, the measured acceleration A is smaller since G calculated based on A, so resulting experimental value ends up in lower than 9.8. So that's the reason. Uh, the physical explanation why the value of g is less than expected value. Now, the student want to confirm that the acceleration is same whether the rolls up or rolls down the ramp. Students start the cart from the bottom and give the cart a quick push so that it rolls up the ramp. Momentarily comes to rest. When it is at the top, the x-axis is still defined parallel to the ramp and origin at the top of the axis. Okay. Now, on the following graph, sketch the position and time velocity as a function of time that correspond to the scenario shown while the cart moves up the ramp. Okay. If the in this scenario, cart is pushed from the bottom towards the origin, x is equal to 0. So we have to know position versus time graphs. The cart start at high x, value of x is high, so moves toward the 0 when x value is 0. So it slow down as it is goes up. The graph should be downward opening parabola at start high and ends flatten out horizontal slope. Horizontal slope means zero velocity because it's come to rest at the top of the position. So that's the graph for the x versus t of the cart when it is moving upward. Now velocity versus time graph. So we can say cart is moving with the negative direction toward the origin. Since the velocity start at the large negative number, gravity pulls it in the positive direction down the ramp. So velocity becomes less negative over the time linearly until it approaches to 0 at the moment when cart stop. The graph is a straight line with the positive slope starting negative and crossing 0 at the stop moment. As you can see in the green line segment, that represent the velocity time graph. As you can see, it start with the negative value but end up with the 0. So that's the answer. If you have any query, kindly ask in the comments. If you like the content, kindly subscribe and share it with your friends. Okay, take care.